Welcome to the lecture on slope. Today we're going to talk about how you can find the slope of a line given a graph, given an equation, given 2 points, all different scenarios. So let's start by how you calculate a slope given the graph of a line. The first thing that we're going to do is pick 2 good points, and by good I mean 2 points that you know exactly what their coordinates are. Ideally you want to find 2 points that line up directly on some grid marks. Once you find those 2 good points, then you're going to count the rise, which is going up and down between the 2 points, and the run, which is going left to right between the 2 points. And rise over run is our slope. So for example, on this first graph, I want to identify 2 good points. Lots of choices here. I'm going to choose this point right here, which is at 0, 1, and this point right here, which is at 1, 4. Now I'm going to count rise over run. Now you can start with either point, it doesn't matter which one you begin with, you just want to be consistent. So if I start with the bottom point, then I have to go up 1, 2, 3 units. And because I'm going up, that would be a positive 3, and going up would be your rise. Then to get to the point, I have to go over 1 to the right. Again, going to the right is positive, so that is called my run. So in this case, my rise is plus 3, my run is plus 1, and when I reduce, 3 divided by 1 becomes 3, and that is called our slope. Okay, let's try that with another line. On this next example, again, you want to start by finding 2 good points. So I'm going to pick this one right here, and maybe this one right here, and we're going to start by calculating our rise over run. Which point you begin with, again, doesn't matter. So this time, let's start with the higher point, and that means I'm going to have to go down 1, 2, to get to the height of the second point. Since I went down, that's in the negative direction, so my rise is -2. Now let's count how far over we need to go. We've got to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the right. To the right is positive, so my rise over run is -2 over 10, and we want to make sure that we reduce that. Dividing both the top and the bottom by 2 leaves me with a -1 on top and a 5 on the bottom. So my slope is -1/5. Notice that in the first example we ended up with a positive slope, and that line is what we would consider to be an increasing line. It rises from left to right. In the second example, our slope was negative, and we would consider that to be decreasing. It falls from left to right. So let's summarize some of those findings. Lines with a positive slope are increasing and rise from left to right, so they're going to be slanted in that direction. Lines with a negative slope are decreasing and fall from left to right, so they would look something like that. Lines with 0 slope are horizontal. That means they have no rise to them, so they go straight across. Lines with undefined slope are vertical, and that's because they have no run. They don't go side to side at all. Okay, so you want to have that memorized. Horizontal lines have 0 slope, vertical lines have undefined slope. So we just talked about how you find slope from a graph. You find 2 good points and you count rise over run. The next thing that we're going to do is figure out how to find out the slope if you're given 2 points. So if you're given any 2 points, I'm going to generalize here by calling them x1, y1 and x2, y2. Then the definition of slope is change in y over change in x. This little triangle symbol actually stands for change. It's the Greek letter delta, and it represents in mathematics the word change. So we want the change in y over the change in x, and by change that just means the difference. So we're going to take our 2 y values and we're going to subtract them, and on the bottom we're going to take our 2 x values and subtract them. Make sure that you do y's over x's, because remember, rise, which is going vertically up and down, over run, which is the horizontal. The other thing to notice here is the order. It doesn't really matter which order you subtract. In my formula here, I started with y2 and went y2 minus y1 over x2 minus x1. You could also do y1 minus y2. You just want to be consistent in the denominator. So if you start with y1 on top, you'd want to start with x1 on the bottom. So make sure you subtract in the same order, but it really doesn't matter which point you start with. So let's practice this formula. Here are 2 points. We want to find the slope. So my slope, which is typically designated by the letter m, is going to be the change in the y's over the change in the x's. Which y should I start with? It doesn't matter. I'm going to start with this first one. So negative 3 minus the second y value, 3. In the denominator, since I started with this y, I have to start with this x. So I'm going to start with the 4 and subtract my negative 6. Now notice here we do have quite a few negatives. In the top, negative 3 minus 3, those are both negative, so you actually are adding there. 3 and 3 is 6, but the answer stays negative, so negative 6. In the denominator, you have a double negative, so the minus minus becomes plus. 4 plus 6 is 10. So our slope m is negative 6/10. You want to make sure that whenever you're giving a fraction for an answer that it's always reduced. And this fraction is not reduced because it's divisible by 2 on the top and the bottom. So if we divide by 2, we're going to end up with negative 3 on top and 5 on bottom. So my slope is negative 3/5. For the next example, we're going to do the same thing. Our slope m is the change in y over the change in x. So I'm going to again start with this first y value, 4, and then I want to subtract my second y value, 4. On the denominator, since I started with 4, I want to start with this 2, and 2 minus the other x value, 0. Now let's simplify. 4 minus 4 is 0, 2 minus 0 is 2, and 0 divided by anything stays 0. So here our slope is 0. And remember, if you have a slope of 0, what kind of line do you have? Horizontal. So this is actually going to be a horizontal line connecting these two original points. Okay, last example. To find our slope, we're going to do change in y over change in x. I'm going to start with, let's start with this y this time. So I'm going to start with 7 and subtract my other y value, 3. Since I started with 7, that means I need to start with negative 1 on the bottom and subtract the other x value, which is also negative 1. So when we simplify, 7 minus 3 is 4. Negative 1 minus a negative 1, remember a double negative becomes a positive, so this is really negative 1 plus 1, which is 0. Now remember, when you divide by 0, that is undefined in mathematics. We can't do that. So 4 divided by 0 is undefined. So how do we write our solution? You could write either undefined, or sometimes we just say there's no slope. Either way is correct. If you have no slope or undefined slope, that means we have a vertical line. So the line connecting these 2 points must be a vertical line. Okay, so we've calculated slope from a graph. We've calculated slope given 2 points. Now we're going to calculate or find the slope from an equation. So the steps to take for that is to put the equation of your line into slope-intercept form. That's y equals mx plus b form. This is a very, very important form to have memorized. It tells us the slope m, because that's the coefficient of x, but it also tells us the y-intercept. That's what b represents. So m is slope and b is y-intercept. In these problems that we're going to do, the only number we're interested in is the slope m, that coefficient of x, the number in front of x. So if we were given an equation like y equals 2x minus 4, we get very lucky in this example because it's already in y equals mx plus b form. It already is solved for y. So all I have to do is find the coefficient of x, which is the number that I see in front of x, and that's what m should be. So in this problem, my slope m is just 2. I don't have to do any work. On the next 2 examples, these should look a little strange. These are lines, but they're a little bit different because in the first case you only have y and there's no x, and in the second case you only have x and not y. So you want to remember that when you have these two special kinds of equations, these are your special case lines. When you have y equals to a constant, that is always the equation of a horizontal line. And what you want to have memorized is the fact that the slope of a horizontal line is always 0. So again, we're not really doing any work here. We're just recognizing that we have a horizontal line to begin with, therefore its slope must be 0. In the second example over here, x equals a constant is always going to be the equation of a vertical line. And what you want to have memorized for that is the slope of every vertical line is undefined. So just recognize that you have a vertical line to begin with, therefore its slope must be undefined. Alright, now when we go to the last example here, this one we are going to have to do a little bit of work on because it's not in our y equals mx plus b form. It's not solved for y. We have the x's and the y's together. So to put it into this slope-intercept form, we want to isolate the y and get it by itself. So to do that, I'm going to need to move this 3x term over to the right side, and I'm going to do that by subtracting. When I do that, notice we still have the negative and the 2y on the left side. Don't forget your negative. And on the right side, we have 6 minus 3x. Now to finish solving for y, we need to get rid of that coefficient out front. So I'm going to divide all the terms on the left and all the terms on the right by negative 2. So that'll give me y by itself, and then we want to simplify. 6 divided by negative 2 is negative 3. Negative 3 divided by negative 2, a negative divided by a negative becomes positive, and 3/2 doesn't reduce, so I'm just going to leave it 3 over 2 and put that x to the side. Now we have this solved for y, so all we have to do to figure out what the slope is, that m, is find the coefficient of x. Remember, m, your slope, is the number in front of the x, so in this problem, that's this positive 3/2. Make sure you take the sign with it. So my slope is 3/2. Okay, in the next set of notes here, we're going to focus on two types of lines that have a relationship with their slopes. First type of lines that we're going to talk about are parallel lines. And parallel lines are two lines that never intersect, and one quality that they have is that in order to be parallel, they have to have equal slopes so that they're slanted in the same direction. Perpendicular lines, on the other hand, do intersect and they form right angles, and what the relationship there is that perpendicular lines have slopes that are opposite reciprocals. Now what does that mean again? Well, for example, if I told you that one line had a slope of 2, then the perpendicular line would have to have a slope that's the opposite sign, so negative, and the reciprocal slope. So if I have 2 and I flip it over, it becomes a 1/2. So opposite reciprocals here would be 2 and -1/2. Switch the sign and flip it over. Okay, so what we're going to do, a very common example and question that you're going to be asked, is to be able to tell whether or not two equations are parallel, perpendicular, or neither. You could try graphing these, but that's a little bit time consuming and it sometimes is not very exact. So all we're going to do to figure this out is we're going to find the slopes of our two equations and compare them. And if the slopes are equal, then we have parallel lines. If the slopes are opposites and reciprocals, then we'll have perpendicular lines. And if neither is the case, then the lines are neither parallel or perpendicular. So how do you compare slopes? Well, you need to get the slopes from your two equations. And how do we do that? Remember what we just did. We put our equations into that slope-intercept form by solving for y, and the slope is going to be that coefficient of x. So for example, on these two equations right here, we want to tell if they're parallel, perpendicular, or neither. So we're going to take one equation at a time. I'll start with the first one. and we want to find its slope. So that means solving this for y, isolating y. So I'm going to add 4x to both sides. So that gives me 3y equals 4 plus 4x. And to finish solving for y, I'm going to divide through by 3. Clean it up. I get 4/3 plus 4/3 x. So what's the slope of this line right here? It's the coefficient of x, which in this problem is positive 4/3. Now we're going to do that exact same thing, but for the second equation. So let me recopy it. And we want to find its slope by solving for y. So I'm going to isolate y by adding 8x to the other side. It gives me 6y equals 8x plus 0, or just 8x. Divide through by 6, and then reduce. 8 and 6 are both divisible by 2, so when I divide by 2, I'll get 4 over 3x. The slope of this line is going to be that coefficient of x, the number in front of x, which in this problem is 4/3. So the slope of this line is also 4/3. When I compare the two slopes, they are equal, so that means the two lines must be parallel. Okay, so let's try another example. Same idea. You're going to take one equation at a time. I'll take the top one. We're going to solve it for y. So here I would have to subtract 5x from both sides. That leaves me with negative 3y equals negative 2 minus 5x. And then I need to divide all three terms by negative 3. There's lots of negatives here, so there's going to be lots of canceling. Negative 2 over negative 3 becomes positive 2/3. Negative 5 over negative 3 becomes positive 5/3 x. The coefficient of x, the number in front, is the slope. So the slope of this line is 5/3. Okay, let's do the second equation. Same thing. Solve it for y by isolating it. I'm going to subtract 3x to both sides. I still have my negative 5y on the left side, negative 8 minus 3x on the right side, and I'm going to divide through by negative 5 everywhere. Lots of negatives again. Negative 8 over negative 5 becomes positive 8/5. Negative 3 over negative 5 becomes positive 3/5 x. The coefficient of x in this problem is that positive 3/5. Now we're going to compare. We have 5/3 for one line slope and 3/5 for the other line slope. These are neither. It's a little bit tricky here. They are reciprocals, however, they are not opposite reciprocals. So that means they're not perpendicular. It's really tempting to want to say that they are. Alright, let's try one last example. So we're going to take this equation here, 3x minus 5y equals negative 1. Solving for y requires that I subtract 3x to the other side. So I have negative 5y equals negative 1 minus 3x. Divide through by negative 5 everywhere. Lots of negatives. And when I cancel out all my double negatives here, I get 1/5 plus 3/5 x. Coefficient of x is that positive 3/5. Now let's take our second equation. I'll come down here, recopy it. Solving for y means I want to subtract that 5x to the other side. I get 3y equals 2 minus 5x. Divide through by 3, and I get y equals 2/3 minus 5/3 x. So the slope of this line, the coefficient of x, is negative 5/3. Now compare. We have 3/5 and we have negative 5/3. They are opposite signs and they are reciprocals, so these two lines are perpendicular. Okay? Alright, in our last example, we are going to do a word problem. We're going to find a rate of change. Rate of change is another way of talking about slope. So rate of change is synonymous with slope, which is our change in y's over our change in x's. So in this problem, we are told that in 1990, there were 11,338,000 students enrolled in grades 9 through 12. In 2005, there were 14,818,000 students enrolled in grades 9 through 12. Find the rate of change of enrollment over time for this data, write the appropriate units for this rate of change, and interpret its meaning. So the first thing I want to do here is identify a couple of ordered pairs that are two numbers that go together. And in this example, it makes sense to take your year, 1990, and your number of students enrolled and sort of think of those together as forming an ordered pair. So I could write the ordered pair 1990, comma, 11,338,000. So the X's here are the years, the Y's here are the students enrolled. Similarly, in 2005, we have this 14,818,000, so I'm going to write that as an ordered pair. 2005, comma, 14,818,000. Now that I think of these as ordered pairs, we can use our slope formula, which remember is y2 minus y1 over x2 minus x1 on these two ordered pairs. And slope, remember, is just another way of talking about a rate of change. So our rate of change in this example, or our slope, is going to be these two y values subtracted. So that's going to be 14,818,000 minus 11,338,000. Doesn't matter which one you start with. I usually start with the larger one. Those are the y's. On the bottom, since I started with the 14 million number, I need to start with the 2005 number. So my first x is 2005, my second x was 1990. Now here you're going to want to use your calculator. When you subtract the numerator 14,818,000 minus 11,338,000, you end up with 3,480,000. In the denominator, 2005 minus 1990 is 15 years. Now we take out the calculator again and go ahead and simplify. When I divide 15 into the numerator, we get 232,000. Okay? So our rate of change is 232,000. Now let's figure out what units should go on this and what this means. To figure out units, you just need to look back at how you calculated your slope. Remember, our slope up here from our formula were y's over x's. So the units of our slope are going to be units of y over units of x. So what were the y numbers? Remember our ordered pairs? Our y's here represented students enrolled. So we have students enrolled on top. Those are the units of y. And our x numbers here were years. So the units on the bottom are going to be years. So let's put those units on our rate of change. We have students enrolled over years. Now to make this a little bit more understandable, it's often a good idea to take your rate of change or your slope and put it over 1 so that you can kind of read out what this statement is saying. It's saying we have 232,000 students enrolled per 1 year. And think about what that means in the context of the question. Since we're talking about enrollment over time, this sort of implies that we are gaining, and the reason I'm saying gaining is because this is a positive rate of change, a positive slope. We are gaining 232,000 students in enrollment per year. So our rate of change means that enrollment is increasing again because our slope was a positive number, by 232,000 students per year. So to get your units of your rate of change, take the units of y over the units of x and then you're just going to interpret that by writing it as a sentence. Okay, that concludes our lesson on slope. Good luck.